Hello guys, how are you? I am Advik and this is my new channel Concept Gurukul. In this channel, we are going to learn class 12 basics of three subjects: physics, chemistry, math, helpful for JE. Okay? So, Concept Gurukul, clear the base, win the race. Let's get started. So today we are going to learn new topic, algebra of matrices. Before knowing what is types of matrices, we need to know what is a matrix. Okay, what is a matrix? A matrix is a rectangular array of numbers, real or complex. That array is called a matrix. Okay. The horizontal lines of numbers are called rows and the vertical lines of numbers are called columns. Okay. Now the data whatever we write inside is called as the entries, elements or entries. So let's take an example. This is a rectangular array and it has vertical lines are known as columns and horizontal lines are known as rows. Okay. And how many columns are there here? 1, 2. So we'll write columns 2. Okay. And then the number of rows 1, 2, 3, 4. 2 cross 4. Okay. So this is how we represent a matrix. And this is a rectangular array of real or complex numbers. The vertical lines are rows. The vertical lines are columns and the horizontal lines are rows. Next comes how we represent a matrix. This, if A is our matrix and A is equal to brackets Aij, okay, and Aij m cross n. This is our formula. This is our way how we represent a matrix. Okay, I will call as ith row. And J as jth column. Okay, jth column. And don't get confused with this X sign. This is not multiplication. This is a way how we represent the rows and columns. We know M is columns and N is rows. Okay, so this is how we represent the matrix. Now let's start. Start to know what are the types of matrices. So we have number 1, row matrix. The matrix having only one row is called a row matrix. For example, 1, 2, 3. This is a row matrix. Only one row. Row means horizontal line. Okay, this is row matrix. These are all easy things. Like my one-time explanation, you'll understand. Next comes column matrix. In column matrix, what do you get? Like similar to row matrix, in this you have only one column, 1, 2, 3. Okay, only one column. I think don't need any explanation in this, right? Yeah, these are just basic things. Next comes rectangular matrix. What is a rectangular matrix? A matrix where M is not equal to N. What is M and N? Number of columns and number of rows are not equal. That means if we take an example, 1, 2, 3, 4, 5, 6. 4, 5, 6. Okay? Here the number of rows are how many? Number of columns are 2. And number of rows are 3. So we can write this as 2 cross 3. See, this is a rectangular matrix because this 2 is not equal to 3. Okay, this is a rectangular matrix where M is not equal to N. Clear? Yes. Next comes number 4, square matrix. Just opposite. Since like row matrix is opposite to column matrix, rectangular matrix is just opposite to square matrix. In square matrix, M is equal to N. That means if you take here one example, 1, 2, 3, 4. We can write 2 cross 2. Okay, 2 rows, 2 columns. Next comes the null matrix. Null matrix. What is the null matrix? The null matrix which has all of its elements as 0. I take all elements are 0. No matter how many rows and columns it has, if all the elements are 0, it is called a null matrix. Simple. Okay. Next comes the diagonal matrix. But before learning diagonal matrix, we need to learn what is a principal diagonal. Principal diagonal. Diagonal. Okay, what is a principal diagonal? For example, let us take a square matrix. If we have a square matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a square matrix. Now the line beginning from the first row, first column element, that means this, to the last element of the last row of the last column, that means 9. So if we connect the line from 1 to 9, this line is known as the principal diagonal. This line is known as the principal diagonal. This won't be a principal diagonal from this element to this, only from the first to the last of the first column and the first row. Okay, this is the principal diagonal. Now once we have understood what is a principal diagonal, diagonal matrix is always a square matrix. Okay, here in the except the elements in the principal diagonal, all the elements are 0. So for example, if we take 1, 0, 0, 0, 2, 0, 0, 0, 3, here the numbers in the principal diagonal are non-zero elements, but except that the other elements are 0, 0, 0, 0, 0. So this is called a diagonal matrix. All clear? Yes. Now let's go to the next matrix. Next matrix comes upper triangular matrix. In upper triangle matrix is very easy. Upper triangle matrix means 1, for example, if we take one example, 1, 2, 3, 0, 4, 2, 0, 0, 3. Okay. Now in the down area, you can see one triangle is being formed. Triangle is being formed on the upper side, top right side. Here bottom left, top right. I am not giving I am not writing the AIJ form. I am just giving you examples, because if you are understanding the examples, that is more than enough. We only have to understand these answers, examples. So as soon as we see a matrix, we will understand. This is a square matrix. This is upper triangle matrix. This is a diagonal matrix. As soon as we see the matrix, it should reflect in our mind that this is this type of matrix. Okay. Let's see the next matrix. Next matrix is scalar matrix. What is a scalar matrix? It is similar to diagonal matrix, but only one small difference there is. If we take 5, 0, 0, 0, 5, 0, 0, 0, 5. What difference you can see in scalar matrix and diagonal matrix? In diagonal matrix, the elements in the principal diagonal are different. Okay, but in the scalar matrix, the elements are same. That means 5, 5, 5. That means we can conclude A11 is equal to A22 is equal to A33. But in the diagonal matrix, if we see here, it's the opposite. A11 not equal to A22 not equal to A33. If for someone who don't know what is A11 means if we have one matrix, the representing style you can say. For example, this is the first row, first element A11. First row, second element 1 2 A22, A33, A4. No. This part will be cut, okay? Fine. Okay, this is the difference between scalar matrix and diagonal matrix. Here all numbers are same. Remember this part. Next comes identity matrix or unit matrix. Both are same. 11. What is it? We'll take unit matrix. Unit matrix. What is a unit matrix? Where let's see the example. With example you can understand in 1 minute, like as soon as you see. For example, this we have 1 0 0 1. Scalar matrix and unit matrix are like this, the same, but the only difference is here A11 A22 A33 not equal to 1, but over here it is equal to 1. If this is equal to 1, if this thing is equal to 1 scalar matrix, then it will become a unit matrix. That's why it is not equal to 1. We can call this as I2 is equal to this, I3 is equal to 1 0 0 0 1 0 0 0 1. Okay, I3 is equal to this. I2 and I2 means 2 rows 2 columns, I3 means 3 rows 3 columns. In this chapter, most important type of matrix is our square matrix. See, after square matrix, all matrices are related to square matrix itself, because square matrix is used in most of the questions and all. Now we understood what is a unit matrix. Now let's see what is transpose of matrix. Transpose means, for example, if we have one number, if we have I6, okay, A is equal to this, then the question will come, A transpose is equal to what? How to solve this? A transpose is equal to, we have to shift the number of rows and number of columns. That means if this is a row, we'll make this a column, and this column will be turned into a row. Not understanding? Just let's write this example. 1 2 3. This row is turned into a column. Again the second row, 4 5 6. Done. A transpose is equal to 1 4 2 5 3 6. Here we have just converted this row into this column and 4 5 6 into this column. Easy? Yes. Transpose of matrix. Am I right? Okay. Understand. Transpose of matrix. Next comes symmetric matrix and skew symmetric matrix. These two are the similar. Symmetric matrix. And first we'll understand what is a symmetric matrix. Symmetric matrix means where A power T is equal to A. What is A power T? A transpose. Means when you transpose a number, it will turn out to be the same. When we transpose this, it will turn into the same matrix as A. Now let's take one example. 1 2 4 2 0 3 4 3 5. Oh wait. My handwriting is not good. Please kindly adjust with it. I'll try my best to improve it. Yes. Now when we transpose this, just transpose this, we have to convert into a column. 1 2 4 2 0 3 4 3 5. Doesn't it look the same? 1, 2, 4, 1, 2, 0, 3, 4, 3, 5. So when we did the transpose, this is A transpose, this is A. When we transpose this A, it turned to be the same as A. So that is a symmetric matrix. And in a skew symmetric matrix, it's a power t. Wait, let me write. Skew symmetric matrix. Okay, in skew symmetric matrix, it's just the opposite. A power t is equal to minus A. That means A power t is equal to minus A means, if we take one example, 0, 2, 6 minus 2, 0, 4. Okay, and in one rule is there, in symmetric matrix and skew symmetric matrix, the matrix should be a square matrix. If a question comes, identify whether it's a symmetric matrix or skew symmetric matrix. You first check if it is a square matrix or rectangular matrix. If it's rectangular matrix, directly leave it. If we transpose this minus A, right? So we have to do minus all everywhere. Minus 2, minus 6. 2, 0, minus 4. 6, 4, 0. Isn't it the same? We have just changed the signs in transposing it. We transpose as well as change the signs of it. Okay. So I think this is skew symmetric matrix. I think you are all clear with these all types of matrices. If you have any doubt, please mention it in the comments, and we'll shout out the name and clear it in the next class. See you. Bye bye. Concept Gurukul will meet all of you again. Bye.